try to lift a weight from a swimming pool and then try to lift the same weight from the edge of the pool, you will notice that it feels heavier when it is out of the water. This was supposed to have been first explained by the Greek scientist Archimedes. He said that the water exerts an upward force or upthrust on any object in it. When you weigh an object in the air and then in water, the difference between the two readings show the upthrust, which is often called the loss in weight of the object. All liquids and gases are known as fluids. A fluid exerts an upward force when an object is immersed in it partially or wholly. This property is called upthrust or buoyancy. It is denoted by Fb. Upthrust can be greater than, equal to, or less than the weight W of the body. This upthrust determines whether the body floats or sinks in a fluid. If Fb is greater than W or Fb is equal to W, then the body will float. But if Fb is less than W, then the body will sink. Upthrust, being a force, is measured in Newton, N. Lifting a bucket of water from a well, pulling a fish out of water, and a body weighing less in the air than in vacuum are examples of the effects of upthrust. Let's look at the properties of upthrust. The larger the volume of the body submerged in liquid, the greater is the upthrust. The more the density of the liquid, the greater is the upthrust. You must have observed that when you put an empty can with the lid on into water, it floats. This is due to the upthrust in the water, since the volume of the can is more. Similarly, if a bunch of feathers and a stone of the same mass are allowed to fall through the air, the stone comes down faster than the bunch of feathers. The reason is that the upthrust due to the air on the bunch of feathers is greater than that on the stone, because the volume of the feathers is more than that of the stone. If you push identical pieces of cork into two different liquids, say water and glycerine, you will notice that your fingers experience more upthrust in glycerine as it has more density than water. The upthrust due to a liquid on a body depends on the volume of the body and the density of the liquid. The upthrust is equal to the product of the volume V of the body submerged in the liquid, the density ρ of the liquid, and the acceleration due to gravity g. Thus, Fb is equal to V rho L g. You must have observed that if you drop a piece of iron into water, it sinks. This is because the force of gravity is greater than that of upthrust. Take identical masses of iron and cork and place them on the surface of water. See what happens. The piece of iron sinks, while the cork floats on the water. This is because the density of iron is greater than that of water. Now you know that if ρ is greater than rho L, then the body sinks into the liquid. If ρ is less than rho L, or if ρ is equal to rho L, then the body floats on the liquid surface. Do you know why fluids exert an upthrust? When the amount of pressure that acts at a certain point in the liquid from all directions is equal, it causes an upthrust. When a block is immersed in a liquid, pressure acts on the lower part of the block, which is greater than that action on the upper part. Thus, the difference in the pressure between the two parts of the block causes the liquid to exert an upward force on the body. This is upthrust.